Welcome to the end of chapter 8. So we're going to talk about the precision, why precision is important, as well as nice precision that we get from predicate logic that English doesn't get. And we'll make a conclusion for this chapter as well. So one of the things that I think is really important to pause and kind of specify here is we're not really doing much with predicate logic yet. Okay, this chapter is all about just kind of introducing it and propositional logic as well, right? We're introducing logic to use it later. We'll use it a little bit in the next chapter when we get into proofs, but really this predicate logic has heavy uses in machine learning / AI. So that's you'll be taking a course on that next year in this program, and yeah, this should be a very useful building block for it. And kind of that's the point of this course, right? This course is a topics course. We talk about all these different things, sets and functions and structures and counting and proofs and logic. We don't get into too deep into any of these, but all of these, right? So you have some level of fluency, some level of familiarity with them. So when these concepts come up in other specific classes, right? You've seen this before and you know what to do with those tools. We're introducing tools for you to build stuff in other classes and other materials in your computer science journey. So that's what we're doing here. So specifically, some of the stuff that predicate logic can be useful for is like creating new truths from existing truths. So again, that's big in machine learning. So I'm thinking stuff like if we know that A is true, and if we know that A implies B is also true, well, what can we conclude, right? That means that we know that B must be true. If we know A is true, we know A implies B is true, then B must also be true, right? Or similarly, we could do something else, right? If X and Y is false and Y is true, well, X has to be true. Okay. You can think about those if it's not immediately obvious, but that's pretty much what we got. So I'm also now going to talk about like why precision is important. Not so much why precision is important, but the niceness of that, the fact that predicate logic is so precise, right? English is pretty messy. If we say something like, let's think of a company, and in that company, if I tell you that some employee belongs to every department, what does that mean? Well, it could kind of mean two different things, maybe even more than two different things. Does it mean that there's one employee out there that is a member of every single department? That would be pretty wild, but that is kind of what it sounds like. Or does it mean every department has at least one employee, that no department's empty? Right? Every department, yeah, there's some employee that belongs to every department, in that, which one does it really mean? It kind of sounds more like the first to me, but the first doesn't really make sense. So maybe it means the second. It's just kind of messy language. Whereas in predicate logic, we can really make this obvious, right? If we wanted to say the first thing, that there is an employee that belongs to every department, we could say that with predicate logic. Right? There is an employee, and that employee is a member of every department. We could say that with the following. And again, if you want to challenge yourself, try to write both of these interpretations with predicate logic and pause the video right now. It is really good practice. To do that, we'd say there exists an X, and we don't have to specify here, such that employee of X, so that's right here where we're saying that they are an employee. There is an X that is an employee, and the following is true. For all Y in the set of departments, right? And we'll specify what D is, but D will be the set of all departments. That's our intentional definition of D. Now the extensional definition of D, remember to extensionally define a set, we would want to be listing all the elements in the set. We'd be listing all the departments, but here we're just describing the set by just saying, oh, it's a set of all departments. So there is an X such that X is an employee, and for all departments, X belongs to it. So we could, introduce this predicate saying X belongs to Y. So there is one X that does all of this. That would be one interpretation, of kind of a silly interpretation, but it's kind of what it sounds like to me. And we could write that with predicate logic this way. There is an employee that belongs to all departments. Or does it mean the other thing, right? That no department's empty. Does it mean the other thing where there's an employee in every department? We could write that this way. For all Y, there exists, oh dear, what happened there? We got a double Y. I've heard of a double U, but I've never heard of a double Y until now. Ha ha. Okay. For all Y, right, there exists an X such that employee of X and X belongs to Y. And we could write that with this predicate like so. Okay. And again, seeing another instance of order mattering, right? Is there an X for which this is true for all Y? Or is it true that for all Y, there is some X, right? Is there an X for each Y, or is there an X for all Y, basically? The order matters. We're really, again, seeing that here. And in the English sentence here, it's a little murky, but predicate logic can really clarify some things. Of course, if you're not comfortable with predicate logic, then maybe this looks like nonsense, but we've introduced predicate logic. We've practiced predicate logic. And so now this just clarifies everything. The sky opens up. All right. And that's pretty much what I wanted to say about precision here. That's one of the advantages to predicate logic. So to kind of summarize everything that we talked about in all of this chapter, right, we talked about a few main things. The first thing that we talked about was propositional logic. Okay. We looked at these propositions, propositional logic. We looked at these propositions, and they were known as atomic because the propositions themselves could not be decomposed into smaller propositions. So an example of some atomic propositions were the sky is blue, I'm wearing a red shirt, I have a beard. Okay, these are all statements with a truth value. And then we manipulated propositions. We combined and got compound propositions with our 6 operators. Most of them were binary. Some of them were unary. Remember, binary operators means it's operating on 2 things, in this case, propositions. Unary operators meant it only applies to 1 thing, in this case, 1 proposition. All right, we had or, we had and, we had not, we had XOR, we had implies, we had the equivalence one, right? These were all of our operators that we talked about. We introduced truth tables, and we said, okay, that's a good way of seeing whether something is true, or maybe when something is true, right? If we don't know what the truth value of our propositions are going to be, and we have some kind of compound proposition, well, we can kind of use truth tables to identify when it might be true, when it might be false. If it was true all the time, we said it's a tautology. If it's true none of the time, it's a contradiction, but we didn't really introduce that word. We'll talk more about contradictions in our proof chapter, which is coming up next, and that's pretty exciting. All right, and then we finished with predicate logic. Finish this chapter with predicate logic, which again is more modular. Propositional logic is kind of simple, not as powerful. Predicate logic is, they're functions really, right? They're functions or relations. We can apply all that mathematical power to predicate logic, and they're very modular because we can put different things inside of them, right? Instead of writing a proposition for every single X, we can just write a function and then put whatever X we want inside of that function to determine whether someone is an employee or even something is an employee. It could apply to a lot of different things. Okay. And that's kind of what we did here. So some cool building blocks for logic. We'll use some of this in our proofs chapter coming up, and you'll use more of this in your other computer science courses in the rest of the program, most notably like machine learning and AI. Let me know if you have any questions, and I hope you enjoyed it. Have a good one.